And we're back and still better than ever in 16-2 where we're dealing with concentrations of solutions. In the last podcast we walked through how we come to know of our dilution relationship of M1V1 equals M2V2, where once again the M1 is the original concentration. By the way, I'm going to use this bracket to denote concentration, and that a little zero behind it simply means initial. V1 is the initial volume. That's an E, not a giant L. That's an E. And then the M2V2 refers to as the final concentration after the dilution, and this will be the final volume after the dilution. So let's go ahead and tackle some problems here. It says how many milliliters of 2 molar magnesium sulfate must be diluted with water to prepare 100 mils of 0.400 molar magnesium sulfate. So you know you're doing a dilution. What you need to do is determine what you know and what you need to solve for. So if we set up our relationship of M1V1 is going to equal M2V2. Do we know the original concentration, M1? Well, yeah, it's 2 molar. That's what you're starting with. So we have 2 molar solution. Do we know the original volume before we do the dilution? The answer is no. The question is how many milliliters must be diluted, so we don't know what the original volume was. Do we know what the final concentration is going to be? Sure we do. We want to make 0.400 molar. The final concentration must always be less than the initial concentration because you're adding water and diluting it to a lower concentration. And do we know what the final volume will be after the dilution? Sure do. It's 100 milliliters. Alright. So now all we need to do is solve for V1 by dividing the 2 molar over to the other side. So when we divide by 2 molar, we divide by 2 molar. Of course, the molar divides out. You have V1 equaling 0.400 times 100 divided by 2, and that should be 20.0 milliliters of original solution. So what that means, if we can draw a picture of this, what that means is we're going to take a solution of 2 molar magnesium sulfate. We're going to measure out into a graduated cylinder we're going to measure out 20 milliliters of that. We'll go with, say, yellow here. Okay, so you have 20 milliliters of your original solution. Then what you're going to do is you're going to pour that into a volumetric flask, a 100 milliliter volumetric flask. It looks like this. And it's got a hard line on there, which is 100 milliliters. This is a volumetric flask. So you're going to pour that 20 milliliters into the bottom of this flask. And then you're going to take water, go with a light blue here, and you're going to fill it up the rest of the way with water right to the top of that meniscus. And when you're all said and done, you're going to have a new solution it's going to be less concentrated, so we'll make it a pale yellow. And it's going to be sitting right on that line. And this will be 100 milliliters of our 0.400 molar magnesium sulfate. All right. Okay. Let's go ahead and move on to the next podcast. I'm sorry, the next example. Example number 6. How many milliliters of 3 molar NaOH can be prepared from 100 milliliters of 9 molar NaOH? So, again, writing out our equation, we're just going to keep everything in black here. M1V1 equals M2V2. Do we know the original concentration? We have to read the question. Don't assume that the first one is always the original. It says how many milliliters of 3 molar sodium hydroxide can be prepared. So you're going to end with this. You're preparing it from this. So this is all the initial stuff right there. So originally we have 9 molar sodium hydroxide. We have 100 milliliters of that. We're going to make 3 molar sodium hydroxide. And the question is, how many milliliters can we make? That would be V2. So if we divide both sides by 3 molar, of course these terms divide out, the molar units divide out, you're left with milliliters, which is good because that's what the question is asking for. V2 then, our final volume, will be 9 times 100 divided by 3, which is going to be 300 milliliters. So we can make a total of 300 milliliters of 3 molar sodium hydroxide from 100 milliliters of 9 molar sodium hydroxide. Let's try another one. If 125 mils of 1 molar HCl is diluted to 800 milliliters, what is the new concentration? It's a dilution, so we use M1V1 equals M2V2. Do we know the original concentration? Yeah, we're starting with 1 molar HCl. Do we know the original volume? Yeah, we're starting at 125 and diluting it to 800. So our original volume is 125 milliliters. Our final volume will be 800. We do not know the final concentration. That's what the question says. What is the new concentration? So we'll put M2 there, and our final volume again is 800 milliliters. And now we just simply have to solve for M2. Divide both sides by 800 mils. Divide this side by 800 mils. These two terms divide out completely. The units of milliliter divide out. And now we're left with 1 times 125 divided by 800. And so therefore M2 will equal 0.156. The only unit that was left was molar. We're looking for concentration and molarity, so we're good. All right. So, example number 8 is one you can try on your own. In the next podcast, we'll go over that, and then we'll tackle 2 other ways of expressing concentration, percentage by volume and percent by mass. We'll see you next time.